Okay, hello everyone. So this is the introduction video for the lab 5 and also I will talk a little bit about the lab practical. Right. So first of all, you need to know the schedule. So March 5th, there are three things you need to submit: the lab write-up, the lab report for the lab 5, and the lab practical, and also the pre-lab. Don't forget the pre-lab for lab 7. So on March 5th, you need to submit those three things. So that's kind of a lot of work for this 2 week. So don't wait until last minute. Okay. And you can see here on the course website, there is a guideline tell you how to write the report. So please check this before you start to write your lab report. Okay, so let's talk about the lab practical first. So this is lab practical. As you noticed, there are two portions: the take-home portion and uh, the in-lab portion. So yeah, just check the rules on the Brightspace. Okay, so and for question one, okay, the question one, uh, the meaning of the circuit model is not the simple. Okay, so for example, the wattmeter is not something like this. Okay, so this is not a wattmeter. You need to check the lab manual. Okay, so all the answers should be, you can find it in the lab manual. Okay, so yeah, just make sure you're clear on this. All right. Okay, so yeah, just make sure you check the announcement on the Brightspace before start doing the lab practical. And also you may notice this part is related to the lab 5. So make sure you understand everything on the lab 5 before you start do this part. All right, so then let's talk about the lab 5. Okay, so the superposition. Firstly, let's talk about the prelab. Okay, so here this is a prelab circuit. Okay, so when you have the superposition, you can, when you use the superposition method, you can solve the circuit with multiple voltage source. For example, this one, there are three voltage source, V1, V2, and V3. DC, I think second one is triangle wave, or yeah, second one is triangle wave, and the third one, V3, is the sine wave. And how to use the superposition is you calculate each individual source separately. Okay, so then you plus them together. That's your final V out when those three voltage sources turn on at the same time. Okay, so firstly, let's calculate V1. So the V1 is uh, so V1 is corresponding to V out 1. So in that case, only V1 is the voltage source. You need to ground. So don't forget, you need to ground the V2 and V3. So in that case, you have this circuit. And we can transfer this circuit to this one, which is R1 in series with R2, R3, R4 in parallel. Okay, so you can see because the current go to R1 first, then go to R2, R3, and R4 at the same time. So that's why those three resistors are in parallel. And this will give you the way out one. You can simply use the voltage division um, to calculate the way out one. So as shown in here. So that will give you way out one. Then you can calculate Vout2 and Vout3 with the same method. And remember, when you have Vout2 and Vout3, those will give you equation instead of the value. You will have some equation related to sine wave and triangle wave. Okay, so then the final answer should be like a equation or a function with sine wave and triangle wave. All right, then let's talk about the tasks. So for Lab5, there are 4 tasks. The task 1 and the task 4 are continue with the prelab. Okay, so let's talk about the task 4 first, which you will build the circuit in prelab on LT space. Okay, basically, you will build something like this. So this is the circuit in your prelab, and you need to plot individual way out due to V1, V2, and V3, which means you need to plot each way out 1, way out 2, way out 3. How you can do that is simply after you build a circuit, and you can just, so for example, I'm trying to plot way out 1 due to voltage source 1, V1. What you need to do is you just make V2 and V3 short to ground. And this, after you run the transient simulation, will give you the way out 1. Okay. And the same thing for Vout2 and Vout3. You need to short V1 and V3 when you do Vout2. Okay, so some of you may confuse how to build the triangle wave in the in LT space. So because there is no triangle wave in the LT space selection, voltage source selection, so you will need to use pulse wave to generate a triangle wave. What you can do is you need to set the T on time to 0. That will give you a triangle wave. Okay. All right. So that's task 4. Don't forget to include all the screenshot. Okay. And then task 1 is just continue with prelab. You will build this circuit, the prelab circuit, on the breadboard, and you will do the same thing like task 4. You will plot the V1, V2, V3 separately, and then measure the way out when they are turned on together. Okay. And the same thing you need to do is when you build this on breadboard, and when you times way out 1, you need to make sure this R2 and R3 is connected to ground. Okay, so don't forget this. You cannot just plug out V2 and plug out V3, then you measure the way out. You need to make sure these 2 nodes are short to ground. Okay, so that's for task 3. That's for task 1. And you can verify this result and this result by comparing them together. So they should give you a similar result. Their plot should looks similar. And then the task 2, the survey equivalent circuit. Okay, so if you say, so what survey equivalent circuit is this? Okay, it's just a voltage source in series with a resistor. And if you check the question 1, it has the requirement of you want the VTH, the survey equivalent voltage 2.5 volt, and the survey equivalent resistance 1.5 k ohm. What that mean is after you build this circuit and you put all the components on the breadboard, when you measure the voltage at here, okay, so this is a circuit on this task. when you measure the voltage on here, it should be 2.5 ohm, 2.5 volts. Okay, and when you measure the resistance according this 2 point, this resistance should be 1.5 k ohm. Okay, so how you can approach to get those values is starting with those two values. Okay, the 1.5 k ohm and 2.5 volt. Okay, so those two values will give you two equations. Okay, first of all, let's consider about RTH. So as I mentioned, when you measure the resistance across these 2 points, you will get 1 k ohm. And how you analyze circuit is something like this. Okay, when you measure the voltage, I mean the resistance, the current goes through like this way. Okay, go this way. And since this is a voltage source, you can look put it as short circuit. Okay, voltage source looks like short circuit. If this is a current source, that's open circuit. Okay, so since this is a voltage source, we just short it, and you will get this circuit, which is just R3 in series with R1, R2 in parallel. Okay, this equivalent resistor circuit should equal to 1.5 k ohm. Then this is the first equation you get. Then you will use VTH to get second equation. Okay, so this is the equivalent circuit with this one. Okay, so when you want to measure the voltage, okay, so what you want is you want to measure the voltage will be 2.5 volt. Okay, when you measure the voltage, you have a voltmeter in here. Okay, so something like this. And remember, voltmeter has a very large resistance, which means there will be no current goes through this road. Okay, no current, which means the voltage at this point will be same voltage at this point because there is no current goes through R3. So then you can analyze this circuit without R3, which you should familiar. This is just a voltage division circuit. Okay, and you make sure the voltage at here should be 2.5 volts. With whatever value you give for with Vs R1 or R2. Okay, so in that case, you will have two equations because of this circuit and this circuit, but you have four variables, R1, R2, R3, and Vs. So you will have many solutions. So whatever the solution is okay, just make sure your calculation is right. You can use any solutions. All right. Okay, then, so that's task one. That's the question one. Then the question two is you want to develop a method to measure the survey equivalent circuit. So what's that mean is for example, you are given this circuit, but you don't know the RTH and the VTH. So only thing you can do is you can deal with these two nodes. Okay, so for example, you can use DMM to measure the resistance, or you can use voltmeter to measure the current, I mean voltage. You can use ammeter to measure the current. So whatever method you use, you can only deal with these 2 points. And then you use those methods to get this value, okay, those value, RTH and VTH. Okay, so then you need to write down your method. Click. Okay, so you need to write down your method in here. So what you want to do is you need to write down step-by-step method that any other students in this class can follow your method easily. Okay, so that's question 2. And the question 3 is just after you get the value from question 1, you apply those value and build the circuit on breadboard, and then you apply your method to verify you should get the correct value, which is 2.5 volt and 1.5 k ohm. All right, that's question 3 and question 4. And then the task 3. So this task is continue with task 2. Okay, so remember, don't plug out your circuit after you finish this part. So if you check the question 1, question 2, what that means is you need to replace this circuit, this voltage source to the AC voltage source instead of ADC voltage source, and you need to put 516 ohm resistor at your output. Okay, so this is your output. You put this resistor at output, and then you measure the output voltage. So basically, this is a circuit diagram of question 1 and question 2. Okay, so then in question 3 and question 4, you're going to build this circuit. Okay, the buffer circuit. How you can build the buffer is based on this LF356N, this chip. Okay, so what this chip looks like is, let me Google this. So it's something like this. Okay, you can find this in your lab kit, and there should be a. So remember here, this is a half circle. This is a mark tell you the direction. Okay, so for example, this tell you this 2 pin, this pin and this pin is pin 1 and pin 8. Okay. So how you can build this circuit is this circuit diagram corresponding to those pins in this layout diagram. Okay, so for example, first of all, this plus sign and the negative sign, that's the input. That's corresponding to the pin 2 and the pin 3. Okay, so pin 3 is the positive input, pin 2 is negative input. So negative input, positive input. And then the VCC and the VSS, that's the power supply for this chip. Okay, so that's corresponding to pin 7 and pin 4, which is V plus, positive power supply. V minus, negative power supply. And one thing you need to do is, there are many students before made this mistake, is you don't want to flip those 2 pins. Okay, so always the positive, so in here, the positive 5 volt apply to pin 7. The negative 5 volt, apply to pin 4. Okay, so if you accidentally flip them, what will happen is you may break this chip and you may burn this chip. Okay, so don't do this. And then the last output, way out, is just pin 6. Okay, so what I usually do when I build this circuit is I build this circuit, and then before I turn on my voltage source, I need to double check every pin is correct. And then I turn on my voltage source and turn on my signal. So I think it's maybe it's a little bit hard for you to first time you build the IC chip on your breadboard. So there is a reference video, so right here. So this video tell you how to build this kind of circuit on the breadboard. Okay, so yeah, like here. So you can check this video as a reference. All right. Okay, so that's task 4, and the question 3 and question 4 is combined, as I mentioned, is combined with this task 2. So you will build this circuit. So this part is the task 2 circuit. This part is the task 3 circuit. You need just connect them together and measure the way out. Okay, so this is circuit diagram for the task 3, question 3 and question 4. All right. So yeah, that's all for this lab, and so I didn't talk about everything for today's lab, and also the lab practical. Just let me know or let other TA know if you have any question regarding to the today's lab, and don't forget the deadline is March 5th. Okay. So yeah, that's it.